Good afternoon, all, or good morning, depending upon where you are joining us from. Welcome to today's webinar on Trafficware's SynchroGreen, our real-time adaptive signal control technology. My name is Kristen Bridgers. I'm part of the marketing team here at Trafficware, and I will be moderating today's webinar. All that means is that I'll be fielding any questions that you might have to our presenter, and I'll be keeping track of and managing our time today. Our presenter today is Jason Orr. Jason is based in Austin, Texas, and is one of Trafficware's most knowledgeable when it comes to adaptive deployment. Should you have questions for Jason during the webinar, please use the Q&A feature. The Q&A feature can be found at the bottom or top of your screen in the control bar. Simply click Q&A, a window is going to open, and you can type your question. We will be answering the questions at the conclusion of today's presentation. Also note that you are able to upvote questions by clicking the thumbs up button below the active question. At the conclusion of the presentation today, we will be sending a follow-up email with helpful links and resources, as well as a recording of today's webinar. So without further ado, I'm going to hand it over to Jason to get started. Jason?
Hey, thank you, Kristen. Hello, everyone. As Kristen said, my name is Jason Orr. I'm Cubic Trafficware's SynchroGreen Adaptive Specialist for the Central region of the U.S. I've been in the traffic industry for about 16 years now, working with different manufacturers and distributors of transportation products and solutions. I think first we're going to conduct a little poll real quick regarding those of you that are online that are current users of SynchroGreen, and if you are here to learn about it maybe for the first time. So we're going to conduct that real quick if we could.
Yep, Jason, the feedback is rolling in. Thank you all very much.
Okay, great. So like we said, today we're going to talk about Trafficware's adaptive traffic signal technology, SynchroGreen.
The agenda will be as follows. First, I will give an overview of adaptive traffic signal technology, and then I will present how SynchroGreen's background and our optimization approach to adaptive signal control. We will then discuss some of the outcomes that we've determined with Trafficware's deployment through analyzing with different technology, and we're going to follow then up by any questions you might have after the presentation. So to begin, what does an adaptive control system do? An adaptive control system adjusts signal timings based on surges of traffic. And what are some of these examples of surges of traffic? The AM and PM rush hour traffic that occurs in almost every agency and community in the US. Surges of traffic can also come from the release of grade schools and colleges, second and third employment shifts at factories and hospitals. Surges of traffic can also happen during times of retail business and at event centers where traffic will build up leading up to the event. And then once again, once the event is over, as everyone is leaving that area. Another example would be the traffic caused by the surges of traffic caused by accidents. Accidents can cause the motorist to take a different path, creating a different traffic pattern in the area, and therefore causing these unpredictable surges of traffic in other areas. Some of the things that a user of adaptive will look for in a corridor that is controlled by adaptive would be a decrease in travel time through the corridor, and in turn a decrease in delay. Also, the mitigation of congestion allows for a reduction in emissions. This can also make an adaptive project a candidate for an air quality grant. There's also studies that have been done that show when the progression through a corridor is improved and that start and stop effect is reduced, and those folks that are jockeying for position to try to get through the corridor, when that is reduced, it can also be a safety aspect. Also, the reduction in emissions. This can make an adaptive project a candidate for an air quality grant as well as these safety grants that are out there. So in summary, an adaptive solution can be a very powerful ITS tool. I will say that adaptive is not a magical tool that you can just deploy and walk away from and expect never to need to adjust. It is important to keep things like the detection maintained and also some of the parameters within the system finely tuned to get the best benefit. Before we discuss SynchroGreen's capabilities, I want to briefly discuss why some of the agencies debate using adaptive. One of the reasons agencies are hesitant to use it is use the adaptive control system is compatibility with their existing infrastructure. An example of that would be possibly an agency running a different central system that is not compatible with the adaptive solution being proposed. Another reason an agency may not want to deploy is the complexity of deployment and maintenance. There also might be some potential restrictions on the agency's multimodal systems. And an example of this would maybe be functions in a controller that are required for an agency to use multimodal systems, and this adaptive could possibly be being performed outside of that controller. And finally, it might be perceived that the system is too expensive. If you really think about what it takes to time a corridor and to continue to keep it timed well, as the volumes change over time, along with those unpredictable surges of traffic that can never really be captured completely in traditional timing plans, that can create a loss of time to the traveling public. And those benefits of an adaptive system start to outweigh the cost of deployment. I'd like you to keep in mind these 5 bullet points here as we go through SynchroGreen, and I just describe how it was designed and invented and deployed into communities to help overcome these 5 bullet points. So now let's take a look at SynchroGreen's background and optimization approach. SynchroGreen is actually a module within Trafficware's ATMS platform. As you can see here, there's numerous modules within Trafficware's central system, our ATMS platform. And some of those include, you can see there, signal performance measures, connected vehicle, emergency response, transit signal priority, and a host of other solutions and modules. Trafficware designed our adaptive module in this way because we understand that there are agencies out there that are not currently a Trafficware customer. So their infrastructure would not support Trafficware's adaptive module. So when you acquire Trafficware's adaptive system, you actually get our ATMS for those intersections for that adaptive deployment. Meaning you can still capture all the remote communication central system capabilities with our ATMS for that SynchroGreen corridor deployment. Now let's talk about how SynchroGreen was built for transportation networks. SynchroGreen, it's a software-based system and it runs on the traffic controller. This is an important feature that allows typical signal operations to remain. And that's the difference between a software approach and a hardware approach, which I'll talk about in the next slide. So again, the adaptive program resides on the controller and it's not a separate piece of hardware. So Trafficware has an ATMS central system, right, that some agencies may use citywide throughout all of their intersections and corridors. Or that agency may only use our SynchroGreen in one corridor in which they would get the ATMS foundation that allows for any triggering systems and allow for maximum flexibility. So a triggering system is kind of, if you think of it as an if this, then this function, meaning if something is happening out on the roadway, the SynchroGreen can adjust. And an example of that would be if you had a detector set up to measure volume. And once that volume hit a certain threshold, maybe the SynchroGreen adaptive would kick in, like if it was at nighttime or during non-peak hours, when SynchroGreen wouldn't typically be running. Another example would be if you set the system to trigger SynchroGreen to turn off at a certain number of detector fails were being recorded. If you had some detector points out there that up to a certain number were failing that wouldn't allow SynchroGreen to run correctly, you can actually it will then turn off and fall back to time of day. We've seen a lot of federal funded adaptive projects that require a systems engineering portion. So when an agency is applying for that funding that requires a central system almost as much as the adaptive system, they're able to check off both those boxes that they're able to fulfill the requirement of having that ATMS central along with the adaptive that they're trying to procure. It also works in conjunction with multimodal and pedestrian measures. The adaptive solution was designed with all of the multimodal solutions coming online in the traffic industry these days. And finally, what's unique about our adaptive is that a lot of you may know that we also, Trafficware, have a product called Synchro. And SynchroGreen is the only adaptive system out there that is compatible with the Synchro and Sim traffic for adaptive modeling and simulation. If we're able to get Synchro files from that agency, we can run a simulation and kind of give the agency an idea of how much reduction in travel they may achieve with adaptive running on a particular corridor. And that's very unique to SynchroGreen. And in turn, I'll say it was designed to eliminate total delay. Some adaptive systems out there will concentrate on pushing cars through the main lines. SynchroGreen was designed to take more of a balanced approach and take into account those vehicles turning off the side streets into the main lanes, especially those times when the side street traffic surges at different times of day. And that's usually where your complaints come in a lot too, right? Those side street folks that are waiting. So like I mentioned, SynchroGreen resides in your current controller. So there is no black box or white box, if you want to call it, no extra hardware required. We took this software approach so as to not introduce another piece of hardware into the cabinet. No extra hardware means no extra points of failure. You know, the more assets you have, the more assets you need to maintain. And this also saves on that cabinet space, that valuable cabinet space, the real estate in that cabinet that just seems to be disappearing as more and more peripherals and solutions come about. So again, our solution runs completely on the traffic controller. It does run on a very easy to use NTCP based local controller software. The controller would be running one or two types of our software, either our Scout or our Patriot version 76. Both of those platforms have the SynchroGreen functionality built into them. This way, all that needs to happen is that once the license are obtained, the SynchroGreen functionality, all you have to do is type in a key that unlocks that SynchroGreen that already resides in that local software. It's very easy to enable for the users. So now let's talk about the communication piece. Communication is required for adaptive. With SynchroGreen, any type of reliable communication will work, and that includes fiber, radio, wireless, cellular modems, communications. All of these communication technologies have the ability to transmit data over the Ethernet, which is how the data is received. Trafficware has added some fail-safe measures into the system. For example, if that communication into the corridor is interrupted, the system can be programmed to continue adaptive operations at the intersections that are not affected. And so what will happen for those intersections that are affected by the communication loss, that controller will simply fall back to the time of day plan that's programmed into that controller. So a little bit about the system topology. There's two main components. Here we have a central server, and that's usually located back at the TMC of the agency or maybe the agency's offices. And that server is receiving data inputs from those local controllers out in the field in that adaptive corridor, which are fed by the detection in the intersections. The central can be an actual server located in the TMC, or it can actually be based in the cloud. We're seeing more and more clients interested in the cloud-based services. So what happens is that central takes the real-time detection that's coming from the field through the controllers, and it then pushes out a timing plan, changing those splits and cycles and offsets. We'll talk a little more about how that works in the slides coming up. So regarding detection, for detection is very important for an adaptive system, well-maintained detection, and it can actually be any reliable source that the agency prefers. Mostly agencies are either video or they're radar, they're one or the other. It really doesn't matter what type of detection as long as it's reliable. It can be even magnetometers, which are in-ground sensors. Those, if you don't know what those are, those pretty much replicate what a loop will do. And this was important for us in developing SynchroGreen, as we did not want to introduce any type of proprietary detection system that would be forced upon the agency that they would have to adopt and use. But again, it needs to be good detection, it needs to be well maintained, and this detection also needs to be placed properly. Here you can see this illustration of some detection placement. We have an illustration showing the detection being placed there at the stop bar. We would want detection at the stop bar at every traveling lane. That would include the through lanes and the turn lanes. And the zones need to be on a separate channel coming into the controller. The smaller the detection zone, the better for us, because we're measuring what we call green utilization at those detectors. And what this does is it allows us to identify and measure the gaps between traffic. We do have some detector calibration measures within the software that allow us to adapt to maybe detection zones that are larger that you don't really want to change, like, for example, loops that are out there. We're able to calibrate within the system to calibrate them down to a smaller type zone to allow us to get the information we need. In addition to that stop bar detection, we have advanced detection that you can see there through the main lanes. Only on the main lanes would we need that. And what that does is it helps us to adjust the offset. This would typically be a 200 to 300 foot setback from the stop bar. And again, this would need to be on separate channels going into the cabinet controller. As you can see there, if the intersections there in the middle are closely spaced, then advanced detection isn't really necessary, meaning that intersections that are close together, the offset adjustment is not something we're really required to adjust much to get that progression we need. So what are some of the basics of SynchroGreen operation? SynchroGreen it's a real-time adaptive control system, meaning we're taking the detector information in real time from the field, and we're adjusting the signal timing in a cycle-by-cycle basis. Some of those adaptive solutions out there will take a few cycles before that information is pushed out. And the reason we didn't take that approach, and I guess I could maybe refer to the ACS Lite that only used the cycle and splits to adjust. And the reason we didn't take that approach is because by the time that timing plan is pushed back out to the intersection, that environment that was calculated in real time a few cycles ago has already passed, and it's changed. It's a different demand once that timing goes out. So our optimization approach is one that uses cycle and the splits and the offsets. And those can change from one iteration to the next. They may remain the same, or they have the ability to change every cycle if needed. Our system also adjusts signal timings based on the current traffic conditions and unpredictable surges that are often caused by those schools and event centers and retail centers. Of course, like I mentioned earlier, those accidents. And having said that, adaptive, it's not a solution that should be implemented in every corridor. This isn't something you adopt as a citywide deployment. Adaptive should really only be put on those corridors that show these unpredictable surges in traffic that are caused by these things that we talked about. Also, in the development of SynchroGreen, we wanted to make sure that some of the standards in the traffic industry were being utilized. Most importantly, the NTCIP-based standards, interface, and that NEMA signal phasing standards, which really is so important when it comes to relating to traffic engineers and abiding by some of the requirements of possibly some of the solicitations that come out that put out for a technology adaptive procurement. So a little more about our optimization approach. Like we said, SynchroGreen uses cycles, splits, and offsets to calculate the period and the phase allocation and the start time of each cycle. And it does this on a cycle by cycle basis. They can be adjusted every cycle as the detector information comes into the controller. Thresholds can also be set for these cycle lengths and splits and offsets, meaning the user can go in and set parameters to allow for a minimum and maximum length allowed. There's also a setting that allows these minimum and maximum split, offset, and cycle lengths to adjust in a way that smooths out the big swings that you may see in demand in these adjustments. So reducing that sawtooth effect. They can also be set to optimize for both single corridors, running north to south, east to west, or it could be optimized to work on a grid network. Some agencies deploy these into single corridors, and some deploy, 2 corridors that are crossing arterials. And what this does is this allows us to deploy into a grid network and that a city may have. So now here's a little more of the meat and potatoes of how things work. We first start with what we call green utilization. Remember, we discussed those detector zones there at the stop bar. This is where we measure that what we call green utilization. This measures the amount of time the detector is occupied. This is the amount of the time that the cars are actually moving over the detector, not sitting there, but actually moving over that detector. And this is the duration of time that is the green interval, if you will, that is effectively used. And that information is compiled then to determine the amount of time each phase should receive under those ideal circumstances. And once that target phase allocations, those are established, SynchroGreen is then able to analyze the system globally, and it'll select that critical intersection and calculate the period duration or cycle length. That critical intersection, that's that intersection that needs the most cycle to run. And so once that critical intersection and its required cycle length is established, SynchroGreen then can proportion that phase allocation or split time, if you will, to all the targets, and then it will assign the cycle lengths to all the intersections in the system. So now for some discussion regarding the offset optimization that we talked about. We discussed earlier that advanced detectors are what is used for that offset optimization. And here we have a typical path, like you see here in path 1, where it's a simple north-south corridor, east-west corridor. But we also have the ability to set up an alternate path within the system. And that would be an example of crossing arterials or a grid network. And the reason for these advanced detectors are so that we can measure where we are seeing the most volume build up and give more bandwidth to those paths that are currently coming on to the corridor, their mid-block of the corridor, if you will. So the offset adjustments are small incremental changes that we will make, and it helps to fine-tune that SynchroGreen to make sure we're getting the best possible reduction in travel time with SynchroGreen. So some of the strategies within the Trafficware algorithm is there's different modes that you can put it in, that the agency can put it in. There's 3 of them there. There's the balance mode, the progression mode, and the critical movement mode. The balance mode and the progression mode are probably the 2 most used modes in the agencies that use our system. The balance mode is a mode of running adaptive where those side streets are taken more into consideration. Those left turns off the main line. These are sometimes where the complaint calls come in. An example of the balanced approach would be in the afternoon maybe, or the evenings and the weekends. The progression mode is where we're focused on reducing the travel time from one end of the corridor to the other end. So progression mode is where we would see it used in the AM and the PM peak maybe, where we're trying to get a high volume of cars through that corridor, where we're trying to get those cars out of the neighborhood, through the corridor, and possibly onto the interstate. And then in the PM, that happening again with the cars coming from the main highway back through to the into the neighborhoods. And then the last one there, the critical mode, that would be an instance where there's an event such as a ball game or a concert where a large volume of traffic would be flushed from a driveway or side street. The combination of balanced mode and progression mode would be what would be used most within the city, like I said. Some of the additional optimization features within the SynchroGreen that help continue these normal traffic operations that are out there. Your preemptions maintained. We're a software-based system, so preemption settings in the controller are maintained. It's compatible with TSP. And as I mentioned before, we are compatible with the multimodal functions such as buses and rail. There's no effects to transition due to the cycle and offset changes. This is one of the things that a motorist might identify when using a typical time of day plan that changes throughout the day. Because all of our movements are taken into account globally, cycle by cycle, these effects of the transition are pretty much absent to the motorist. There's different strategies that are used for pedestrian movements. We have a strategy where there are very few pedestrians and a strategy if there are constant pedestrians. And there's also even one where your pedestrian is very predicted, cyclical, if you will, where the movements are in the morning and in the afternoon. The dynamic critical intersection can be selected as well. This can be done from one iteration to the next. That dynamic intersection doesn't have to be set all the time. So the intersection that requires the most cycle length can change cycle by cycle depending on where the demand is. And also SynchroGreen will allow for multi-serve capabilities. If you need to return and service a phase again within that cycle, it can do that as well. So SynchroGreen can also maintain all of the intersection special functions, such as your overlaps and maybe your flashing yellow arrows. These are all maintained as we, again, are using the controller-based software to do this. So what are some of the outcomes that we've seen with some of the deployments with SynchroGreen? One thing that can be difficult for traffic professionals to determine the results and also to do so in a way they can show possibly city management or other stakeholders is that the measures of effectiveness of a deployed project, right? So one way we do this is we'll use what we call blue toed travel time. A lot of you may be familiar with that. And so you can see here, we have a blue toed device that's deployed at one intersection and then measuring the travel time to another device deployed in another intersection, preferably probably the end of the corridor. And that travel time between those two locations can be graphed as you see here. And it can be done so in a before and after deployment to show those two different travel times. So you can see here, one of those is where it was before the study, and then you can see the achievements in travel time after the study. And this is a really good way to show those that maybe aren't really in the weeds of traffic, or they're the ones that sign off on these projects. You know, a lot of our customers are repeat customers, and it's because they're able to show this kind of MOE to their other agencies within, other departments within the agencies, and even the city council folks that make these decisions. Also, there's another way of measuring, and that's to use the high resolution data. We can take SPMs and we can graph them out to show the data sets like this arrival on green diagram and this Purdue data report. So this is another way to realize your measures of effectiveness on these projects. So that really does it for me for this presentation and for what I wanted to illustrate.
Great. Thank you, Jason. Before we move into the Q&A, I did want to remind everyone that we will be sending an email out to you all with helpful links and resources. That does include a recording of today's webinar. If you're interested in more webinars like this, follow us on social media at Trafficware on Facebook, LinkedIn, and Twitter. You can also stay in the know by signing up to receive our emails. That is, if you don't already. You can email your request to trafficwaremarketing@cubic.com. I'm going to go ahead and drop that email into the comments now. You can just shoot us over a request saying, please add me to your email list. So I'll drop that in the comments now. Jason, it looks like we have a few questions coming in. Are you ready to go ahead and start with the Q&A?
Yeah, sure. So here we have, are the 3 strategy algorithm options a new feature, and how long have they been a part of SynchroGreen? I don't believe they're a new feature. I don't know how long they've been a part of it. I assume here we're talking about the balanced mode and progression mode and critical movement mode. I've been with Trafficware for a couple of years now, and I'm not sure if it's was developed when it was originally developed, or if it's something new. So, but in any case, if you have more questions about that, please reach out. I'll put my email up here at the end. The next question we have is, does SynchroGreen Adaptive work on all types of controllers? So it's our software is what's required. It doesn't really matter what hardware controller it would be, as long as our software is on there. It's that Scout or Patriot version 76. That is what's required. Our local software is what's required. So if that's put on a different brand controller, which we see that happen a lot, that's not an issue. Let's see. Synchro requires a default saturation rate, and SynchroGreen is the road capacity saturation rate dynamic or predetermined. In regards to saturation, I don't believe it determines saturation, but I've never found an answer out there for saturation. I know what SynchroGreen can do is it can take you into saturation later, and it can bring you out of it sooner. So there's not really, it can't fix saturation. Nothing can fix that, but more lanes, right? But there being a default as identifying saturation in Synchro, I don't believe there's actually a trigger for that. Another question here: what happens if the connection to the central server is lost? So what would happen would be that the controller then would just fall back on the time of day plan that is programmed into the controller. If connection is lost between some of the intersections, Adaptive can continue to run in the intersections that are not affected, and the ones that are, it will go back to time of day. But if that communication actually going into the corridor or coming out of the corridor back to the central, if that's completely lost, contractor cuts fiber or something into the corridor, it's simply the whole corridor will just revert back to time of day plans in that local controller. All right, and that looks like all the questions.
All right, it looks like there was one more that we may have to answer after the webinar. Did you see that one come in from Jake?
Oh, let's see. Let me scroll here. I didn't see that. Oh, can you describe how TSP is done in SynchroGreen? That's a question that I will need to refer to my engineers about. It's something new for me and these new agencies using TSP. So I will, Jake, we will get you an answer to that directly.
Yeah, Jake, I have your email here, so I'll follow up with you after the webinar, and Jason and I will connect you with someone that can answer your question in more detail. Thank you. Alrighty, y'all. Well, we have a little bit more time today. We wrapped a little bit early, so we'll hang out here for just another minute, give you time to type any further questions that you might have. Just a reminder, follow us on all of our social media, Facebook, Twitter, and LinkedIn for more webinars to come. We'll also be launching our new website in the next couple of months, so keep an eye out for that. And we'd love for you to sign up to receive our emails. I dropped the address in the comments section. It's trafficwaremarketing@cubic.com. If you'd like to reach out to us and request to be added to our email subscription list, we'd love to have you on there. All right, Jason, well, it looks like, oh, there's one from Nana coming in.
So when a TSP or pedestrian phase is triggered, does SynchroGreen suspend its optimization until the TSP and pedestrian are finished? No, optimization remains the same because we are able to use a cycle, split, and offset. I mean, this is just a transition happening within the system. We're able to pick back up since we're able to adjust cycle by cycle. So the optimization is still there and still runs.
Thank you for the question. We have one more coming in.
Let's see, there's a question. Yes. So each detection zone, each lane needs to be separated out. I know you can put, double loops on the same channel. The reason we need this is for lane by lane utilization. It's part of our calculation. So sometimes we'll go out to deploy, and there'll be some existing detection out there. It might need to be a little bit of supplemental detection. Maybe we say there needs to be some advanced, and that's a great opportunity. We talked about magnetometers earlier. We actually manufacture a magnetometer called a pod. It's a wireless, and to drop something like that out there at advanced is great. But yes, we will sometimes come in and maybe even the video is on two running on the same channel. You'll just have to upgrade the channel there to allow for two different channels coming in. So it does need to be separate.
Great questions coming in, everyone. We still have plenty of time, so if you have some now, go ahead and drop them in the Q&A. We'll wait just a couple more minutes before we wrap up. So go ahead and get your questions in now. Right, looks like we have one more coming in.
Advanced and stop bar, yes, that is correct. Advanced and stop bar lane, they need to be on a separate channel. And this is all due to the lane by lane utilization that and the different detection that is coming in.
All right, everybody. Well, I think it seems like we probably have all of our questions in for today. We want to thank you again for joining us, and thank you, Jason, for a wonderful presentation. We will be following up with an email with the recording and some resources for you. Thanks again, everyone, and have a wonderful afternoon.